This is Joel Richard, and let's see the exercise number 7, which is the implementation of linear and binary search. The aim is to implement linear and binary search, and this is the code. The basic concept of the linear search is to get the elements of the array, and using a loop, it loops to the every index position of the element to find the position of the particular element. In the case of binary search, it sorts the element in a particular order, and finds the mid value, and using that mid value, it searches above that and below that, and if it finds the particular element in the mid element, it returns the mid value, or else it goes above it and searches for element, and below the mid element and searches for the element. Now let's see the code. Mm, we are creating a class def linear search, returning parameters a and key, and for using a for loop, which iterates throughout the length of the a. If the a of I equal to key, but if it finds the element of key, it returns it, or else it returns -1. In the case of binary search, we are giving the parameters ARR, low, up, and key, which is the lowermost value, highestmost value, and the key. And if low, if up greater than or equal to low, we are finding the mid by using low plus up minus low, which is the difference between them, which gives the middle value. If the array of element equal to key, it returns the mid value. If it is less than key, it returns these values to the binary search, and or else if it is greater than, it returns ARR mid plus 1 up and key. If it is less than, it returns low mid minus 1 and key, or else it returns -1. And while loop always true, we are creating a list. Creating a list called L, and we are getting size of the list in n, and we are iterating through the for loop for range n, and in L dot append of int of input gets the element of the list inserted into that, and we are printing the choices linear search, binary search, which should be performed. We are getting the input from the user for linear search and binary search. If the choice is one, that is linear search, it asks the element to be searched using the linear search, and using the position, we are finding the linear search by giving the list and their key. And if the position not equal to -1, which means that this is not empty, it prints that the element found on the index and the position of the element of the index, and it prints it, or else it prints the list element is not found in the list. For choice 2, which is a binary search, it first sorts it, then gets the element to be searched, and we are passing the position binary search, the list 0, length of the list -1, and the key. And if it is not equal to -1, it prints the index of the position, or else it prints the element is not found, or else then the else part breaks it. It is the output. We are entering the size of the list as 3, entering the element 1, 2, and 3. We are choice below as a linear search, which finds the position of the element 2, which is the index position 2, which the index positions are from 0, so these 0, 1, and 2. The same is done for binary search. 1, 2, and 3, another size of elements. Binary search is done, and using binary search, you are finding the position of the element 3, and it is given as 2 after sorting it. And that's it, and thanks.